Loops. Hello everybody, this is Ben Finkel, and in this nugget we're going to take a loop at how you can implement looping code structures inside of the Python programming language. Now for the course of this nugget we're going to first talk about why we want to loop in the first place. What's the point of creating code that's going to loop or iterate through multiple times? Then we'll take a look at the actual code. We'll talk about the for loop and the range function. That's a special function that we can use to supply values to our for loop. Then after that we'll take a look at the very similar but slightly different while loop, which allows us to loop through code while a condition continues to be true during the execution of our program. Alright, let's take a look. When it comes to performing a repetitive task, there's nothing better than a computer. By their very design, computers make quick, efficient, and accurate calculation machines to perform repetitive tasks over and over and over. That's why they're so great, they're so fast at performing math calculations that might take you and I a long time to do and we'd be very error prone with. Once the computer's been taught how to do it, it can perform that calculation and it can execute that performance very, very quickly. But like all things in programming, the key comes in providing the computer with appropriate instructions. So take a look at this little chunk of code up here on screen. This is fairly straightforward. What it does is it takes a number that I define at the top of my code, and then it simply runs through a calculation checking it against all of the numbers between 2 and 9 to see if it's divisible by any of them. And if it is, and it's not the same number itself, when we get to the end we say, hey, that was a prime number. Otherwise we say, you know what, it was not a prime number. But this code has some real problems. Now if you're new to programming, you might look at this and say, alright, well, that looks pretty good. It's going to work. It's fairly legible as long as you understand what the different symbols mean, the equal signs and the percent and everything. But for an experienced programmer, or once you've started programming a little bit, you're going to realize that this is not so great. For starters, I've got the exact same code written over and over and over and so on down the line. In fact, I had to write it 9 different times. Well, that's pretty annoying, right? I mean, what happens if I want to change this code? What happens if I made a typo? In fact, when I was typing up this code, I did have a typo and I had to go through and I had to make that change in 9 different places to fix this code. What happens if I wanted to extend past 9? This code only works up to the number 9. Well, that's not especially useful. I can pretty easily memorize what the prime numbers between 2 and 9 are. I don't need a computer program to tell me that. These kind of things happen all the time, particularly in a production environment. Your specifications change. People come along and say, you know what, the way you just wrote that code, that's fine, that was great, but we actually need it to work a little bit differently. And suddenly you have to go and refactor all your code to meet new requirements. Well, that's a real problem when you've got code stretched out and written like this. And it should come as no surprise that computers and computer programming make it very easy to not do this. We can knock this right off and we can turn this whole bit of code into a loop. And we're going to look at 2 different types of loop during the course of this nugget. The first is going to be a for loop, and the way a for loop works is that you define it with a collection of objects. So you say for x in objects. And then this code is going to loop through and it's going to execute over and over and over on every single object x inside that collection. So if there's 3 objects in that collection, it's going to execute 3 times. If there's 10, it's going to execute 10 times. And we'll talk a moment about how you create a collection of these objects. We're going to use, on the other hand, a while loop, which is a totally different kind of loop. And that's going to take an expression that's going to evaluate to true or false. And as long as that expression is evaluating to true, this loop is going to repeat through its code over and over and over until something happens down here in the code that causes that expression to equal false, at which point the loop will exit out and your code will continue. So we're going to define the blocks of code inside these loops with indented block syntax. It's real easy to do. And of course, we're going to have a colon on the end of this for and while statements. And the last thing that we're going to look at, and we're actually going to talk about early on, is a new function called the range function. Now the range function is what we're going to use to return or create the list of objects that we're going to loop around. If all that seems a little bit crazy, a little bit hairy, don't worry, let's get into some code right now and start seeing how it works. To begin with, let's take a quick look at the code as I have it written. Like I said, all it does is it simply takes a number at the top of the piece of code. Here I've said it's equal to 9. And it runs down through a series of if statements to determine if it evenly divides into any of the other numbers. And if it does, it sets this value, this variable prime, equal to false. So when it gets to the bottom of the code, when it gets to the end, you can see that if prime is still true by the end of the code, then it's going to print out that it's a prime number. And if it's not, it's going to tell me that it's not a prime number. We'll just run it real quick to see it in action. And there you can see 9 equals 3 times 3, so 9 is not a prime number. But I can come here and I can change my code to be 5, let's say. And I'll run my code once more here. Whoops. 5 is a prime number. You can see it was not evenly divisible by anything, so 5 is in fact a prime number. But like we talked about, this code is terrible. When I first wrote it, I left the F on false lowercase. I had, my 9 statements here with a lowercase f and false. Python is case sensitive. That didn't work at all. I had to go and change it in all 9 different places to say prime equal to false with a capital F. That was really annoying. Just a simple, mind blank on my part, and I had to go change it everywhere. Also, the number 5 is hard-coded. Now we could collect it from the user, but it's still stuck to be between 2 and 10, which, like we said, is not particularly useful. So all these problems can be solved with what we call a loop. And let's start taking a look at how loops work and how we can use them. So here's my example that I call the good example, and this is using the first type of loop that we're going to use called a for loop. And notice how much shorter my program already is. We just went from, I think it was 41 lines of code to 15 to do the exact same thing. And all I've done is I've turned that big long series of if statements into this for loop right here. So here's how a for loop works. It starts with the keyword for, and then you have in here your expression that is actually going to be a range of values, and we need to set a value to store each iteration of that range. This is actually called an iterable expression. We'll talk about that in a different nugget. Then I use my indentation level here to indicate everything that's inside the for loop. This is all the code that's going to be repeated for every instance of my range. And then I've got my code, my if statement. And once again, notice that inside the if statement I've indented again to indicate which code belongs to the if statement and which code belongs simply in the for loop. Now this whole chunk of code here is going to execute over and over and over until it reaches the end of the range. So a for loop is used to execute a loop of code over a fixed number or a known number of objects, a known number of times. In our case, we want it to go 9 times on the range 2 through 10. The other important thing that's happening here, and you want to take a look at this, is that the test variable is being defined right here inside of our for statement, and test equals the number inside of the range for every iteration of the loop. So the first time this code runs, test is going to equal 2, and that's what this statement right here is saying. This is the if statement, only now instead of having the number 2 hard-coded into my code, I've replaced it with the variable from the for statement. And so what that allows me to do is turn that previously static code into something that's a little more dynamic. I can repeatedly use this same little bit of code 9 different times, because the second time that this cycles through, it's going to be equal to 3, and then 4, and then 5, and then 6, which is exactly what I want. I want it to scale right up that ladder, walk right up that ladder, and test my number, which in this case is 5, against every single one. Let's just see it in action here. Python goodexample.py. Hey, 5 is a prime number, and I'll go in here and I'm going to change this to 9, save it, rerun it, and 9 equals 3 times 3. 9 is not a prime number. So it works exactly the same as before, but what we've got is, first of all, 30 fewer lines of code, which is great and nice and easier for us to read. Plus, we only have this chunk of code, this if statement, printed once. So if we need to fix it, if I've done something wrong, if I've made a typo in it in some case, I only need to make that change once. It's easier to read, it's easier to maintain, and it's easier to debug. Well, let's take a brief segue to talk about the range function that I used inside of my for clause. That deserves a little bit of attention itself. Range is a function similar to print and input that is going to take a couple of values inside the parentheses, in this case 2 values, but the difference is that it's going to return a value. And what that means is that range as a function not only performs some task, but when it's done, it gives me back a value, a result, from that performance. In fact, it expects it. The computer expects that to happen. Nothing comes out, nothing happens on my screen if I simply run range all by itself. Take a look here. Python range example.py. Right back to my command line. Nothing happened. Even though I called this range function, it didn't print anything out to the screen. It didn't expect me to type anything in. What I need to do is I need to assign the value that's returned from range to a variable. So let's say x equals range. Fair enough. And then I'm going to print x. That all makes sense, right? So now let's run my range example. And you can see what I've got here. I've got the numbers 2 through 8 inside of square brackets. 2, 3, 4, 5, 6, 7, 8. And those are all inside of the square brackets. So x became what's known as a list. And that's what range does. It takes 2 numbers and it creates a list that contains all the numbers in between those 2 numbers, which is great inside of applications like a for statement. And you can see here, all I've done is I've said for test in range 2, 10. So notice that when I did 2 through 9, it stopped at 8. So it's inclusive of the first variable, the first parameter that I put in, the number 2, but it's exclusive of the last parameter that I put in this case the number 10. So using this function inside of the for statement creates a list, a collection of numbers for me that my for statement can then iterate over. Let's take a look at how we can use that in a number of different ways. The for statement is very flexible in Python. So here I've got a quick little bit of code that just takes a range of 5 to 50 and assigns it to the variable numbers, and then I use it inside of my for statement. I say for number in range 5 to 50, print that number. So this should print out 5, 6, 7, 8, 9, 10 all the way up to 50. Let's go ahead and see how that works. Python numbers.py. Woo! There it went. Started at 5. I have to scroll all the way up to see it. And you can see above hand when I printed off just my numbers variable, I've got all my numbers inside of square brackets. And then it went all the way down to 49. Remember, it's exclusive of that final digit. Now, wow, gosh, you know what? That was way too many numbers. I didn't actually want to count by every individual number. I want to count by, let's say, 5s. No, let's say 10s. I'm going to go comma 10. So what this does is this says, once again, produce a range of numbers 5 to 50, but do it every 10. Skip every 10. And we can see that in action here. I will simply execute my code again, and now it's just 5, 15, 25, 35, 45. You can see what happens. It didn't get up to 49, it stopped at 45, and the reason is because the next number in the sequence would have been 55, but we said to stop at 50. 55 would have been too high and outside of our range, so we only got 5, 15, 25, 35, 45. Make sense? One more thing, you notice that I've got my range defined twice here. I had to make that change twice, and that doesn't make any sense. I've already got the range inside of numbers. I can replace this statement here with my variable numbers. Say save and execute my code once again, and you see it works exactly the same. So once I've stored that range inside of a variable, that variable is a list, and it can use a list inside of my for statement instead of the range function itself. I've got my for statement iterating over every individual number in the numbers list. Now, this doesn't only work with numbers, it also works with text variables. And here I've defined my own list. I'm not using the range function. I'm simply saying the names that I've come up with here, separated by commas and put inside of square brackets, just like we saw on our printout of the range function. I've got 4 different names: Ben, Alice, Jack, and Sarah. And then I execute my for statement across those names. So now I've got text instead of numbers, but it works exactly the same. I'll come here and I'll say Python names.py, and you can see first it prints off my list with the square brackets and everything else, and then it has Ben, Alice, Jack, and Sarah. We're all great people. Oh, that's good to know. So you can see how the for statement iterates over or repeats over, executes over the same code as many times as you need it to. And when we come back to our good example from our prime number test here, hopefully you have a good solid understanding of how we're using the for loop here to execute our prime number test. In fact, you may even be thinking that we can now take off the upper limit, and you'd be right. We can simply say, you know what? For range 2 to num, we can run this loop. So if I want to run this code for, instead of 9, I'm going to run it for 90, that's going to work perfectly fine. I just come over here and do Python goodexample.py and run my good example, and you can see 90 equals all of these different multiples of 90. Using the for loop allowed me to completely remove the artificial boundary that I had originally in my statement. I could make this go as high as I want. The only thing stopping me from making it 9,000 or 9 million or 9 billion would be how long it would take to execute. But even that can be mitigated somewhat through the clever use of something called the break command. The break allows us to drop out of the loop prematurely. So I've said for test in range 2 to 90, so this is going to loop through 90 times. Well, that's not actually necessary. The minute we run into another number, another multiple of 90, the minute we get this statement down here that prime is equal to false, we can drop out of this loop. All I need to do is type the word break. And once I save this and run it again, what's going to happen is that it's going to say 90 equals 2 times 45. You know what? We already know that 90 is not a prime number. Break right out of that loop. We don't need to execute the remaining 89 times. We lost it on the very first one. So you can always use this statement break when conditions are right to drop out of your loop prematurely. It just pops right out and moves on to the next line in your code. If our number was something not even, say 25, so it's going to get past 2 and it's going to get past 3 and it's going to get past 4, we can still see that when it runs, it eventually gets to 25 equals 5 times 5. Then it knows that 25 is not a prime number and it drops out at that point. So it doesn't just have to break on the first time. Any time during this loop it runs into that break statement, it drops out, and it saves us the work of running through or looping through the remaining iterations of that for loop. We can even simplify this code a little bit more using the break statement in combination with an else clause. Now you know else from the if statement, but here notice I'm lining it up with the for, and that's really important, the indentation, right? Because the else is on line with the for statement, not on line with the if statement, it's going to apply to the for loop. And in a for loop, the else clause is going to execute when the loop gets all the way to the end, assuming we don't hit the break statement. So this code is going to execute once the loop fully completes. How can we use that? Well, take a look. Here I can say that if we get all the way to the end of the loop and we didn't hit our break, we can print out the fact that this is a prime number. Otherwise, if we did get to our break, I can print that it's not a prime number right up there inside of my if clause. That means I can get rid of this entire second if statement here. I don't need it. And that means I don't need this variable, this prime variable, where I'm storing a flag of whether or not it's a prime number. So I can shorten up my code even more, make it even more, to my mind, legible, simply by making it look like this. So now we are going to break out of the code when we find a valid number, and we're going to print that the number was not prime. Otherwise, if we get all the way to the end, we will in fact print that it was a prime number. And let's choose a prime number 17, let's say, in order to see that happen. So this is going to be a good example 2. Execute this and it says, hey, 17 is a prime number. So a very simple for loop with an else statement and a break statement allows me to produce some pretty complex calculations with a really minimal amount of code. Now let's take a look at the other type of loop that I mentioned we want to go over, and that's a while loop. Now, since we have the foundation of understanding loops underneath our belt, this is going to be a lot easier, a lot simpler to understand. It works basically the same. The only difference is determining how many times we're going to execute through the loop. So where a for loop executes some fixed number of times over a range of values or a list of, say, names, the while loop is going to continue executing over and over and over until some condition that we've identified evaluates to false. So take a look at my code here. What I've said is while add is not equal to 0. So that's my expression, add not being equal to 0. And as long as add is not equal to 0, this code is going to continue to loop through and execute over and over and over. And look, all it does is it prints out the current sum, which starts at the value 0, asks the user how much they want to add, puts that value that the user keys in into the add variable, adds it onto the sum, and then it goes up to the top again. It loops through and it executes again. And check out here, I say type 0 to end the program. So if the user types in 0, this code is going to get to the bottom, it's going to go back up to the while statement, and it's going to see that now add not being equal to 0 evaluates to false because add does equal 0, and this will break out, and that'll be the end of my code. So this is really neat, right? As a developer, as a programmer, when I'm writing my program, I don't know how many times this is going to loop. I don't care how many times it's going to loop. The user is now in control of this loop, and that's what the while statement, the while loop, allows me to do. Let's see it in action. Let's see what happens here. Python add.py. And an error message. Oh, and it says name add is not defined. So what I was not allowed to do is I was not allowed to define the add variable inside of my where statement. I actually need to define it up above. I need to create it before we get to while. So I'm just going to say add equals 0, save this, run it again, nothing happened. Why not? Well, I played a little trick on you here. I set add equal to 0 right off the top, so when we got here to our while loop, add already equaled 0, it never executed a single piece of the loop. We didn't execute once through the loop. What I actually want to do is I want to say add equals some value, any value other than 0. It doesn't matter what I put in here because I'm going to overwrite it with input from the user, but I need to make sure that it's not 0 so that my loop at least runs through once. And I'll come here and I'll say Python add.py. Now you can see it's executing. The current sum is 0. How much do I want to add? I want to add 10. How much do I want to add? 45, 99, 208, 594, 13. Doesn't matter. I'll go on and on and on. When I want to exit, I type 0 and hit enter, and it drops me back to the command prompt. Now, as a general rule, the for loop and the while loop are actually so similar they can be used fairly interchangeably. And here's what I mean. Let's take a look at my example of my prime number test, but this time I'm using a while loop instead of a for loop. And all I'm doing here is I'm simply saying while my test is less than my number, and then I added in a little addition here, test equals test plus 1. So all I'm doing is I'm manually iterating through my test number, which is going to start in this case at 2, and it's going to go all the way up to whatever I define my number to be, and it's going to test against every single one of those. The while loop is going to execute. Let's just take a look here and make sure it still works right. Python good example 3.py. And in fact, you see 90 equals 2 times 4 or 5. 90 is not a prime number. I can test it once again against 17 just to make sure, and 17 is a prime number. So the while loop worked perfectly well in an instance where previously I was using a for loop. Now, this is okay. It's not a great practice, but it's an alright thing to do. And the reverse is also true. I can use a for loop here where previously I was using a while loop. So now I've got a sort of artificial range created. I said create a range from 1 to add, and I initialized add at the value of 10. So it's going to go 1 through 10, but the simple fact of the matter is I want the user to have control of this loop. So what I do is at the bottom of my code, I reset x back equal to 1. So if I didn't have this little if statement here with the break, this loop would actually run infinity times. It would run over and over and over. It would never stop, and the computer program would never end. We can see this in action here. If I type Python add 2.py, and it's working just like before. The current sum is 0. I'm going to add 10. I'm going to add 39. I'm going to add 15. When I'm ready to exit, I just hit 0 and it drops me right out. So I used a for loop, but it didn't execute a fixed number of times. I was able to make the for loop operate somewhat like a while loop. And once again, this is an okay thing to do. It's not a great practice. It's a little less clear, a little more difficult to read than the while loop. And of course, if I forgot that break statement, if I forgot to create a condition where the loop could exit, the loop would execute forever. We would have a never-ending program. So it's important when you're writing loops in your code to understand what might be the best loop to use for any given situation. What's going to make your code the easiest to read and the easiest to maintain and the least likely to have any bugs in it, and use that type of code, use that type of loop, all the while knowing that you can always implement either one to do pretty much the same thing that either one is doing. That concludes this nugget on creating loops in the Python programming language. Just to review real quick, we talked about why we want to create loops. How writing repetitive code over and over and over is not only difficult to read, but it's also difficult to maintain and update as our requirements and our specifications change. We saw that with a loop, we can take a large piece of code and shrink it down to a much shorter, smaller piece of code. We also saw that we can make it a lot more flexible. When we hard-coded each of those statements, each of those if statements, we had an upper limit depending on how many if statements we typed in. Well, once we turned it into a loop, we were able to introduce variables, and we could loop any number of times that we needed to, so we could scale up our loop without scaling up the size of our code. We took a look at the exact implementations of both the for loop and the while loop, which operate the same way. They just have different conditions for how many times they loop through. And we talked about the range function, how we can use the range function to produce a set of values that the for loop can loop over. I hope this has been informative for you, and I'd like to thank you for viewing.